Okay, example 3. An app is being marketed to people at a starting price of 20 bucks. And 300 people are okay to buy this app at that price. But they do some research and they find if they increase the app by $5, so instead of $20, go 25 or maybe 30 or 35. But for every time they increase by $5, they lose 30 people. And so at what price could we find the maximum earnings? So there's the word maximum again. So I'm going to write that off to the side. Maximum earnings. So that's what we're trying to find. Ignore the fact that I barely even wrote the word earnings there. So your earnings, like anything that you ever try to sell, will always be the price. So the app price, how much earnings depends on what is the price that you're selling for, and then the number of purchases. So what's the price you're selling for and how many people actually bought it? So that's what we're looking at maximizing. In the previous question, we wanted to maximize area. So we went length times width. In the other one, we want to maximize the product of two numbers, A times B. And so here we're trying to maximize the earnings. So we're going to go app price times the number that actually buy it. So this one is a little bit nicer because we don't actually need another formula because the formula is going to kind of be built in here. So the app price is $20. And if we do that, we get 300 people will buy that. But then there's some variation here. You can, if you want to, you can increase it by $5. And if you want to increase it by $10, you could just times it by 2 or times it by 3 if you wanted to, 15. So what you say is 5x. So x can be any kind of counting number. So if it's 5 times 1, then you've increased it by $5. If there's 2 here, then 5 times 2 is $10. So this kind of helps. It's not just going to be 5. It could be 5, 10, 15, 20. But if you do that, you're going to lose 30 purchases. And we're going to add the x again because it couldn't just be 30. If this x is a 2, then we would get 10. And then we make this a 2, and we would lose 60. So you could increase it by $10, but then we would lose 60 people. So that's why those x's are there. And the idea here is now we actually have a formula, and there's two x's. X times x will get us an x squared. And again, whenever we have an x squared, you're going to get a parabola. And if you find the vertex, you can find a maximum or minimum. So that's what we're looking at here. So 20 times 300 is going to be 6,000. And then minus 600x. And then this would be plus 1,500x minus 150x squared. So these are like terms, the x's. And I'm going to write the negative 150x squared out in front. And then these can combine to, I think, 900x. And the 6,000 will go at the end. So here, we've got an x squared function, so it's going to be shaped like a parabola or a u, and it's negative out in front, so it heads down. Perfect. If we find the vertex, we found the maximum, and that's what we're trying to do. We're trying to find the maximum. So we need to find the vertex. So when you find the vertex, the first thing you do is carry the number down and create a square. Now we do have x's, so I'm going to write an x. Now, start with the middle number, 900. Cut that in half. Well, that's 450. Take 450 and divide it by the number in front, negative 150. So 450 divided by 150 is 3, but then there's a negative sign. So it's negative 3. So this needs to be a negative 3. Now, to find out the other number, you could go x minus 3 times x minus 3, and you could FOIL that, and then you could times it by negative 150. But I'm going to do the cheating method. I'm going to go negative 3 squared times by the number in front, which is negative 150. Negative 3 squared is going to be 9, and 9 times negative 150, 9 times 15, 135, so negative 1,350. Okay, so I'm at negative 1,350 on number line, negative 1,350. Here's 0, and I need to get to 6,000. So I need to go from here all the way to here. So I need to add 7,350. Whoops, 7,350. All right, so normally I have a vertex that is x comma y, but in this case I have x. Yeah, x's are in here, so I still have an x, but my y is e, my earnings. So I've got x comma e. That's how this works. So my vertex is going to be change the sign to a 3, and then 7350. So this is my x, and these are my earnings. So what do we want to know? What price should the app be so that we end up getting the maximum number of earnings? So I'm going to erase this work off to the side. Hopefully you are, at this point, getting comfortable with completing the square. If you're not, you're going to need to find some extra help. Look online or ask me. But, I mean, we're dealing with the thousands here, so it can get kind of complicated. So what do we know? Well, we know our x is 3, and we get a maximum earnings of 7,000. So what's our maximum earnings? Well, 7,350. So that's what our maximum earnings are. But what is the price? What is that? Well, the price was 20 bucks plus any adjustments of 5x. But we know our x is 3. So it's 5 times 3. That's 15. 15 plus 20 is 35. So what's our price? Our price is $35. I think that's all it asks, but how about the number of purchases? Well, because we knew we had 300, but we're losing a bunch. We're losing 30 x's. Now, x's are 3 of them, right? So 30 times 3, that's 90. So 300 minus 90 is 210. So I'm doing 35 bucks for the app, and only 210 will buy it. But that gets me the maximum. And if you multiply that, you can do that. You're going to get 7,350. But those are the kind of questions I can ask. So you can ask, I can ask, how much is the price? Well, 35 bucks. How much more did you increase it? Well, it was originally 20, and now it's 35. So I guess I increased it by $15. How many people are buying it? 210. How many people were originally going to buy it? Well, 300. So how much did it decrease by? Well, that's a decrease of 90. What's your earnings? My earnings are 7,350. So there's a bunch of questions we can ask there. Okay? That's a hard question to do. There is a practice one, so I'd recommend that you do that as soon as you're done this.